Hello, this is Riley Hammond, just doing a quick run through of my Module 3 open-ended project. I guess the simplest place to start would just be my Python class. So this is the current main executable in the current state that this project is in. What it essentially does is compiles some C++ files, two of which are class objects, card and deck, and two of which are executables, main and first, which then get turned into main.exe and first.exe. Now, it'll then read the information from a text file called roundtracker.txt, which, if I delete all the information from it, it will run first.exe, and if it contains information, it'll run main.exe. So let's just say that there's nothing in it right now, and we'll jump to first.exe to show off that functionality. First.exe will create two deck objects for the two players, one of which will be full and one of which will be empty. It'll then shuffle the full deck and distribute its contents equally, so both players have a deck of 26 cards distributed randomly. It'll then pull a card from each, compare them, and distribute them based on who won. What it then does is outputs the results of that to CPP output, just showing the current suit and value of the cards that got pulled, as well as the current deck sizes after one run. And then it'll also write to p1out.txt and p2out.txt, which are just representations of each player's deck respectively to track it across different runs of the program. So I can just show what a run looks like. You can see that currently CPP output.txt looks like this: club heart 72 27 25. What I'm essentially doing here is restarting from a previous test run. So you can see it ran first, then diamond, spade, 8 4 27 25. So what that did was it created two objects of 26, and then the 8 beat the 4. So the new sizes are 27 and 25. So let's then say that roundtracker.txt has a bunch of text in it. What then happens is Python will run main. Now, in order for that to make sense, I will have to go through the rest of the Python first. So after calling whichever executable it does, it'll then read in from CPP output.txt, reformat it, and put it into Python output.txt. You can see that it just converted to file names and reorganized it for how a functional PHP file would be able to interpret it and then update the state of a website. I'll get to that later. That's currently broken, so no point showing it now. But after that's done, it will copy the contents of P1 out into P1 in, and copy the contents of P2 out into P2 in. So if you remember, P1 out, CPP wrote to, C++ wrote to basically store the contents of the deck. It then copies that into P1 in. Now, how that's used is when I finally get to, I'll have it run main.cpp. What main does is very similar to first.cpp, but instead of creating two even deck objects of 26, it'll just take the two from for P1 in and P2 in, then just reconstruct the decks from earlier with the actual saved information. It'll then, like before, run a turn and print the output the exact same way that first.cpp does. As you can see, same file, but slightly different because cards redistributed. And in Python, so you can see the first one was 13 of hearts now versus 4 of clubs. And player 1's deck has grown to 28, while player 2's has shrunk to 24. And Python output has changed to compensate. And P1 out and P1 in, both also currently updated. This can happen a theoretically infinite amount of times. It'll obviously stop working when one player's deck reaches 0 cards, at which point the game ends. So that is the extent of its current working functionality. I guess what I may as well show is what it was also meant to do. So you can see that in word.php, what the page is supposed to do is execute gamestate.py, then read in information from Python output.txt and save it to some variables. It was also meant to write to round tracker.txt, but that's currently broken. Anyway, what the website will do in HTML after that PHP runs will print out some rules, which are also currently outdated, but no point rewriting the rules for a broken website. This is where buttons would be if they were properly used to make the website's functionality, and then it'll display the images and deck sizes using the variables that were set earlier via the text file. There's also style.css, which just defines how the web page is displayed. You can see there's default and secondary text colors as well as backgrounds, different like font families, and I also use a variety of nested grids to handle how information is displayed. I'm going to show you on the website here. This is the default text color and the default background, and then here we have the secondary. Here are the rules in one section. The buttons would be here if they were working, but no point displaying buttons that are currently broken. Then I display the back of the cards with the current deck size, and then I have the suit of the current card and the current card's value. Now what's meant to happen is you would hit a button and refresh, and then this would be different and it would show different deck sizes. However, that is not functional at the moment. Just to show you the grid areas, I'll quickly inspect element. Here's like the main bodies grid. Then there's a grid for main. And then for each section has its own grid, and the two different types of div are also split up. So it'll get a bit chaotic here, but you can see that the section for the image displays is 2x3, and then they each display like different subdivisions of the section for where different cards are positioned. Then the divs that represent the cards here are subdivided further just to display the images cleanly with their numbers and the correct locations. And that is unfortunately the current extent of how this program functions. Thank you.